Hey everyone, welcome back to the Lighting Control System Design video series from Lighting Controls Academy. This is part 3. If you haven't watched part 1 or 2 yet, I highly recommend that you go back and start the series over to see all the information that we've covered already. But if you've already watched parts 1 and 2, welcome back. Hopefully you will find part 3 a excellent capstone to the previous 2 parts, and we are going to be going over installation and post-occupancy. I'm the Education Manager for Lighting Controls Academy, Webster Marsh, and let's get into it. So this video is going to be outlined in a similar format to parts 1 and 2. We're going to start off with how we price lighting controls, so navigating the estimation process, what kinds of pricing we're going to see, and how quoting happens during the bidding process. Then we're going to go into construction administration documentation. Similarly to other kinds of documentation we've seen, we're going to see a little bit of an example of what each of those documents have to offer and how they play into a lighting control system design. Then we're going to go into startup coordination and how we coordinate the different roles and getting our systems up and running and tested properly. Then finally, we're going to go into ongoing support, how we make sure the owners and the occupants are well trained, satisfied, and supported for the long term of the project. So the first thing, pricing lighting controls. When we're getting into a lighting controls project, one of the challenges to lighting controls systems is the pricing process. A lot of people will try to get, price per square foot estimates or price per device estimates, and that's really challenging, especially for the sales reps to be able to do, because it's not like light fixtures where it's just, okay, here's the cost of the fixture and here's the cost of the labor to install the fixture. Lighting control systems really vary widely, as we've already discussed, and so really providing a solid cost estimate takes time and effort, and so the bidding process is just as challenging with that. We really want to make sure that the installers have the ability to review the entire requirements of that system, either via the drawings or the documentation that we provided, so that they can really estimate what kind of scope they're going to be providing, because the bidders, the contractors for the bid, are going to just use that documentation to come up with that bid. So if the documentation is not thorough enough or not complete enough, then there's going to be a lot of issues that come into play with making sure that that was quoted appropriately. And so when these documents are distributed, these people are not familiar with this project. You've known this project from its beginning, but these new players involved really don't have an idea of what to expect from this whole project. So they're trying to get as quick an idea for this as possible, because they're just trying to come together with a quote for how expensive it is, and they're competing against other contractors, other groups that are trying to get involved, and so it's a really stressful time for people to being able to provide quality information. And so that's why a clear control intent narrative or sequence of operations is really important and can really help clarify what is expected from the system, so that the contractors don't have any surprises or any scope gaps. If your sequence of operations is thorough enough, then there really shouldn't be any question about what is required of the lighting control system, and therefore you should be able to, as a contractor, if you're reading a clear sequence of operations, you should really be able to quote that project accurately. So that's why having these documents really thoroughly vetted before they get issued for the bidding process really helps support the project. Now, that's not to say that projects that don't have a bid, for instance in design build, can't benefit from a clear sequence of operations. It's just that there's usually a little bit more direct paths of communication with design build, whereas with design bid build, you have a little bit of a buffer that prevents these direct lines of communication from happening, especially in public projects that might require that people have very formal ways of communicating, and we'll go into some of that in a little bit. But the goal here is to just make your documentation as clear as possible so that there's no question what is being provided. But if you do have a design build project, the having the designer involved through the process, or if you can get the designer involved in the bidding process, and that's not prohibited by any requirements or restrictions from the project, that can really help prevent any issues or errors that come along with lack of clarity. And so even if the sequence of operations is the clearest possible, covers every single detail, there might still be questions during the bidding process. And so having the designer involved to vet the bidding groups, the quoting groups, to make sure that they can actually provide it, it can actually benefit the project at the end of the day. So when we're dealing with bidding, we're dealing with specific roles within the industry. The very first role, which we often see in projects, is a general contractor, or GC, and they're going to overview the entire project, make sure that the total price tag for the project is covered, and they take complete ownership of the project, regardless of any subcontractors that they hire out, such as the electrical contractor. The electrical contractor oftentimes is a subcontractor to the general contractor and works alongside other trades, such as the mechanical contractor or the AV contractor. And so these contractors are at an equal playing field and will work alongside each other to making sure that they provide their scope. And so the electrical contractor is specifically in charge of the electronic components, the controls, the light fixtures, all of the labor and equipment that goes with all of that, to making sure that it's a complete system and functional. There's also distributors and dealers. So these are the groups that are going to purchase and deliver that equipment. So the contractor usually purchases from the distributor or dealer, and the distributor and dealer kind of handles the money, handles the delivery, oftentimes through what's known as a purchase order, where it's an agreement that they will pay on delivery or before delivery, and the distributor dealer will issue those quotes to the contractor. The contractor will then use those quotes to come up with their estimate for what the cost of the project is going to be. The manufacturer's rep, so this is somebody who I've mentioned in past as well, but they are absolutely part of the bidding process or the pricing process of a project, and they will oftentimes be the direct line of communication between the distributor and the manufacturer itself. So if a distributor does an RFQ or a request for quotation, they will send that RFQ to the manufacturer's rep, and the manufacturer's rep will provide a quote back saying this is how much it's going to cost to buy the equipment that you've asked for. Sometimes that's not enough information for the manufacturer's rep to be able to quote. They might ask for actual documentation for the project, and hopefully the distributor can give that. But this is where sometimes there's some challenges with the bidding process, because not everybody has the entire documentation for the project. So making sure that the documentation carries forward can be kind of challenging, and oftentimes there might need to be some back and forth saying, oh, I am not seeing this document, does that exist, can you please check? And so it's not as quick and streamlined as somebody might think, but ultimately at the end of the day, the manufacturer's rep is the one that's kind of on the line for that price tag, and they hand that price tag over to the distributor. Then the distributor hands a price over to the electrical contractor. The electrical contractor hands a price up to the general contractor, and the general contractor includes that price in their entire quote for the project. So there's a lot of layers and steps involved. The last group is integrator, and you might not have an integrator in a project, you may have an integrator in a project. It really depends on which project and the requirements for that project, but integrators really do help coordinate multi-system connections or unique applications such as color changing. And so an integrator oftentimes is going to be a subcontractor to the electrical contractor, although sometimes you'll see integrators as a subcontractor to the general contractor. And there's some nuanced differences between why you would want the integrator to be a sub to the GC as opposed to the EC, but it really, again, varies by project need and the integrator's capabilities as well, and their involvement in the project. But they will oftentimes provide a quote to the EC bypassing the manufacturer's rep and distributor. Oftentimes, we'll also see that the integrator operates as a dealer, and so that's why it can sometimes just bypass the rep and the distributor, because they will actually be reselling the equipment to the EC, to the project, and provide the services to support that equipment at the same time. So that's the kind of simple difference between a distributor and a dealer. Distributors just wholesale equipment, drop ship all the way to the project, whereas a dealer will oftentimes offer services on top of the equipment itself. So pricing, how we break down the price for a system is similar to how we break down pricing for fixtures, but you might not be familiar with some of these terms. So that's why we're covering this. The very first thing, which you might recognize from other things like buying a car, is MSRP, or manufacturer suggested retail price, also sometimes referred to as list price. This is basically what the manufacturer has published as their maximum price that they will charge for this piece of equipment. MSRP is rarely what projects pay for at the end of the day. They often pay a little bit less than that, but if you want sort of a high estimate of how much it's going to cost to have this device on the project, list price is a great starting point to just make sure, like, okay, this is kind of where the budget should be. And really, most projects should not be paying the MSRP. They should be paying less than that. And so if you're going straight from the manufacturer, you'll often have what's called a direct sale. And there are manufacturers out there that do direct sale. You can buy straight from them. You don't even have to go through any other groups to get their equipment. And that's oftentimes going to be the least expensive option if you do that. A lot of manufacturers, however, don't do that because they don't trust that if you do a direct sale from them, that the system's actually going to work out at the end of the day, because there's no oversight. They're just basically taking numbers from you and saying, okay, yeah, here's the equipment you asked for, but they aren't going to be able to vet that sale. They're not going to make sure that that system is complete and functional. And so that's why we have the next step up, which is distributor net or DNet. And that's where the dealer gets a price, a direct sale in most times from the manufacturer. And they will mark that price up a little bit to justify their existence, but also to cover the expenses of them, making sure that that system's actually complete. Good distributors are going to be able to look at documentation and say, oh yeah, there's a gap here, or there's some missing hardware that we need to provide. And so that's sort of the first line of defense as a distributor. They're not going to wring it out completely, but they'll at least do their due diligence and make sure that they have everything they need to go forward with the sale. Then there's contractor net or CNET, and the contractor is going to take that marked up DNet and they're going to mark it up some more to cover the cost of additional labor that might need to be associated with the specific purchase and receipt of that. Freight is usually independent of a DNet markup. You'll see freight or shipping as a separate line item, but the actual cost of the device will have that DNet markup. And then CNET, again, it's what the contractor is going to mark up on top of what the DNet sold them for, so that they can again, roll in the additional costs that are going to be associated with them handling this equipment. Oftentimes you don't see a huge difference between DNet and CNET. It really varies. It depends on a number of factors that I'm not going to get into here, but just something to keep in mind is, again, direct sales the lowest, DNet is the next step up, and CNET is the next step up. On top of all of this, there are groups, if they are worried or uncertain about something, they will roll in overage to cover the additional work that they're anticipating. So for instance, if a contractor sees that there's a major scope gap, they might want to include a little bit of overage to cover the work that's going to have to go into resolving that major gap in the system. And so they'll add in overage. They might not show it as a separate line item in their quote. They might just have a big lump sum number at the end of the day showing, okay, this is what my quote for the system is going to be. But within that, in their own books, they'll probably mark out additional overage just to cover unexpecteds. And so a lot of, for instance, manufacturers reps will use overage as a way of covering startup services for their technicians. So it's a it's a fluid number, and it can get quite tricky to pin down exactly how much overage is going to be put on a project. But it's a common practice with most lighting control systems that there's going to be some level of overage to cover unexpecteds or technician work or additional labor that isn't necessarily listed out someplace. And then finally, labor, which is the biggest variable involved in all of this. It's really hard to pin down how much labor is going to go into the startup of a lighting control system. So making sure that this number can be quoted or at least estimated by a group can really help with the budgeting process. The challenge here is that there is really no best practice for estimating labor, because if it's a simple, copy paste project, maybe the labor is pretty low in comparison. Whereas if it's a color changing facade with lots of layers involved, you're oftentimes going to see that as a higher estimate than your stock estimate. So again, it does vary, but oftentimes, especially with integrators, if you ask them for some level of estimate for the price of the project, they'll be able to give you something. It won't be the most accurate price tag associated with it, but it's at least better than just guessing randomly. So getting a sense of what the cost of labor is, it's a skill that really takes practice to get to a good place with. Next, we're going to go into how we use the different documentation that's involved in the bidding process. So the very first thing, as I've hammered again and again throughout these three parts, is the control intent narrative and confirming owner's intent. That is, at the end of the day, the most important piece of everything involved, is making sure that the owner's intent is carried through the entire project from beginning to end. And so identifying what additional services might need to be involved through the control intent narrative might be helpful, although there might be inferred or implied services that come through without explicitly stating it. Then the sequence of operations is going to provide that measurable criteria that is going to be supported by the bill of materials, the BOM. And we'll go a little bit more into detail on what a BOM is in a little bit, but it's just sort of like a listing of all of the components that are going into the system. The installers, as I mentioned before, are really dependent on the sequence of operations and the control intent narrative so that they can provide an accurate estimate. So they're going to be reviewing all of this documentation very thoroughly. And there are other documents and drawings or specs that they use to supplement. But oftentimes, if you have, for instance, a device quantity on your layout, if you show occupancy sensors and keypads in the documentation, the installers may just use that as their estimate. And if it's a schematic, as I've mentioned before, if that drawing is schematic only, that quantity is going to probably be incorrect. And so as a result, the installer is better suited to providing a quotation based on a sequence of operations than on a device layout that's schematic, because the quantities are probably going to be wrong, so their quote's going to be off. Whereas if they just work off the sequence, their quote might actually be more accurate at the end of the day. And additionally, they will work with the manufacturer's rep, as I've mentioned, to come up with the cost of programming and services that will have to come with that system. And so through that discussion of, okay, here's what the sequence of operations is asking for, the manufacturer's rep can then look and see, okay, this is what we're going to have to do for services, this is how much time it's going to take, and they can provide a pretty accurate quote to how much time it's going to require to start up that system. Then the designer is going to be reviewing and revising their documentation, oftentimes in what's referred to as a bulletin, to make sure that if there's any changes throughout the bidding or construction process, that the documents actually reflect those changes so that the installers have the most up-to-date and accurate information to be able to build the project off of. All right, so getting into the documentation and how construction administration is involved. So now that we've kind of passed through the bidding phase and gone into construction administration, we're now going to see what kinds of documentation you're going to be dealing with here. So the very first one, which oftentimes happens in construction administration, but can happen during the bidding process and can happen even before the bidding process happens, depending on the project type and how it's structured. So RFI, or request for information, what it is it's a formal request for some kind of piece of information from oftentimes the installation team to the design team saying, hey, I don't understand what's going on here. Can you please explain a little bit more clearly? It's oftentimes used to clarify if there's a scope conflict or a scope gap, if there's any field discoveries that happen. So for instance, if you didn't realize there was asbestos above the ceiling and then you discover there's asbestos above the ceiling, oftentimes an RFI is going to come in and say, hey, there's asbestos, what do you want us to do? Because you asked us to tear the ceiling down, but now we need to do an abatement. And so that's part of this whole process if there's uncertainties about the project, especially in renovations or reconstructions. So having RFIs really is a great way of tracking that documentation and making sure that, okay, in RFI number 43, we said this, that did not get captured in the updated bulletin. It should be captured in the next bulletin. And so that way, there's just sort of continuity with this information that's being asked for. And RFIs, sometimes it takes a very long time to respond to an RFI, but making sure that RFIs are responded to in a timely manner really makes sure that the project stays on track for its schedule and helps avoid any assumptions that might be made. If the RFI is sent out and then work continues on that area and there's an assumption that the RFI is going to go in a certain direction and that assumption's wrong, then there might have to be rework that's done. So it really depends, but oftentimes RFIs are just going to screech everything to a halt until there's a response to it. And so making sure that RFIs are responded to quickly and effectively really helps smooth that process along. The other thing is that if there's existing documentation that for some reason never reached the hands of the person asking the RFI, that can help. An RFI might get sent out and then the response might be refer to sheet E301, and if the contractor didn't have sheet E301 for some reason, they might dig into their documents and go, oh, we're missing this sheet. Where did it go? How can we get that document as it was issued? And so that way RFIs are also just a great way of saying, oh, you're missing a sheet here. Are you missing other documents perhaps? And so helping kind of clarify anything that's missing. So oftentimes if there's an answer to the RFI already available in the documentation, the response is just going to say refer to this document instead. If for some reason the RFI results in a change to the project, it will oftentimes result in a change order, which is when the scope or the cost of the project is changed. When there's significant change enough to justify there being a revised quotation, essentially. And so this might be through omissions, conflicts that weren't really vetted, or any, again, unforeseen site conditions. So asbestos abatement is going to be a change order, whether you want it to be or not. Unless, of course, you can avoid opening up the ceiling and leaving that asbestos alone, and the owner is okay with that, you're going to see a rather costly change order on the project. But oftentimes also with change orders, there's impacts on the intent of the project. So again, we didn't intend to abate any asbestos, but now we do. that is a significant change in the intent of the project. There could also be code compliance challenges if something was overseen. For instance, switched receptacles is oftentimes a abandoned scope and needs to be incorporated again, and so complying with that code requirement to have switch receptacles might add additional equipment, might add additional labor. And then additionally, if integration has not been vetted, if it's just a big question mark of like, we know we want integration on this project, but we never really clarified exactly what that integration is going to be, that can really make things quite challenging to the project. And so, again, there might be a change order that involves even hiring an integrator, which was never included in the cost of the project to begin with. And so, oftentimes you'll see change orders increasing the cost of the project. If it decreases the project, it's sometimes referred to as a credit to the project, but it's rare that you get to see a decrease in cost of the project. It's oftentimes going to be an increase with a change order. Submittals. So these documents are critical to the lighting controls designer. They are the confirmation of what is going to be purchased and installed and programmed. And so this is the last line of defense before the floodgates are opened, essentially. If the lighting controls designer accepts the submittal as is, then it's basically full speed ahead. Production's going to happen. Everything's going to get delivered and installed, and then other procedures to start it up are going to be followed. But at the end of the day, this documentation should be a complete system design, essentially. It should be saying exactly what was said in the documentation that the designer provided and clarifying any questions. For instance, if the device layout was just for schematic purposes, this should be the final layout. It should explicitly state where devices are going to go and how they're getting installed. So hopefully you're going to see cut sheets, one-line diagrams, device layouts, a list of services and bill of materials, which again, we'll get into that in the next slide. But all of these should be included in the submittal. If there's any question that the lighting controls designer has as to the effectiveness of the system, then they should be responding back by saying, this is unclear, or please, provide this, or additional information is required to be able to approve the submittal. And so it might get rejected if it's not complete and clear enough. So, and the designer really, at the end of the day, gets that responsibility of saying, yes, this meets what I've designed, or no, this does not meet what I've designed and needs to be revised. So oftentimes when I'm doing a lighting controls design, I'm going to break out all of the documents that I've issued for that project and go, very slowly through all of it, through the submittals, to make sure that everything aligns with what I had specified. Because if there was a missed piece to the project, that submittal is the record, and if I've approved it and there's like a room missing or a bunch of devices missing and I've approved it, well, that's on me because I overlooked that and said, yeah, it's fine. So I'm going to really spend a huge amount of time just reviewing the submittals and making sure that they are accurate and up to date and cover everything that I need them to cover. So I've mentioned this a lot before, but bill of materials, or BOM, this is the list of equipment and services, and it'll even itemize by part number and the quantities of those devices. And this is, at the end of the day, the list that is going to get punched into the system for the manufacturer to fabricate all of the devices and to quantify the hours of labor that are needed to be provided by the technician. And so this is additionally a document that needs to be vetted very thoroughly. It's, as I mentioned, it's for ordering and production, and oftentimes the bill of materials is included in the submittal. And so that bill of material should align with the submittal documentation. And if there's a misalignment, sometimes a bill of material might be quantifying a certain number and that number is different in the submittals. That's another red flag that needs to be identified and said, okay, the BOM or the submittal needs to be revised to reflect the accurate number, because the BOM is really what's going to be used in that production ordering process. The submittal is going to be used in reviewing where things are going to be going, how they're going to be connected, any programming, stuff like that. So both of these documents really need to be thoroughly vetted during the submittal review phase. And so, as I mentioned, you want to cross-check those bill of materials against the drawings and even the control intent narrative sequence of operations for services, because the BOM is going to list those services. So if there's startup services or specific integration services that need to be provided, then that should be included in the bill of materials. And if you have multiple manufacturers, you might have multiple bills of materials, one from each manufacturer. And so reconciling those can be challenging. And so that's why sometimes groups prefer to stay with just one manufacturer for a project, but it's not always possible to do it that way. And so it's just good to be prepared for there to be a couple of bill of materials or multiple bill of materials to be reviewed and cross-checked and coordinated. And so with the services, you might see programming, integration, startup, and training. And all of these, I would say, for the most part, are required for most projects. Training is very critical and a lot of times overlooked or forgotten about because it happens so close to the end, and we'll talk a little bit more about training. But it's just good to confirm in the bill of material list that everything you need is included. Substitutions come up all the time, and a substitution request is a document that's from a different manufacturer or different manufacturer's rep saying, our system is equal to the system you specified, and therefore we want to propose that you use our system, which may come with a discount in comparison to the originally specified system. But a substitution request really should meet or exceed the performance requirements of the system. If we're going through what's referred to as a valued engineering process, or VE, where we are reducing the cost of the system by eliminating features or eliminating components or finding a substitution that, while doesn't meet all of the requirements, does meet some of the more important ones and comes at a better price tag, that's different than just a straight substitution. So in this case, we're talking about just a straight substitution where we're saying you want to basically use brand Y's system in lieu of brand X's system. And so it should meet or exceed all of the requirements that you've stated in the sequence of operations or control intent narrative. And there's oftentimes pre-approval procedures that are required, especially in design bid build projects, because there's very specific timelines that need to be met in those projects. And so if the project is already in submittal phase and somebody's proposing a substitution for the system, it's way too late in the game to be providing a substitute system. So a substitution should really be provided during the bid phase, oftentimes via an RFI or through a formal substitution request application. And so, but at the end of the day, the proposer really needs to prove that their system is equal or exceeding the system that was specified. And the way that I prefer to have my substitution requests provided is to have a complete submittal package, just as though I were reviewing the system that I had specified for approval. This needs to prove to me that, yes, this is going to work, and a complete submittal package is quite a heavy lift for somebody to provide, hoping that it's going to be a substitution. So in that case, the due diligence really is on the person proposing that substitution. But oftentimes, I've seen really good substitution requests come in and have considered it and even approved it if it's if the consideration is thorough enough or the project is actually applicable to that. But there are also times where I've seen substitution requests come in and they have not been fantastic, and we've had to have a pretty serious conversation with the group proposing the substitution. And so at the end of the day, sometimes you just got to say, no, this is not going to work. All right, so startup coordination. I've used this term startup a few times now, and let's get into what that really is. The very first thing you want to do is have a pre-startup meeting, which you're really going to go over the entire submittal. So oftentimes it'll be scheduled after the approved submittal is done, but before there's any delivery or installation of the system. And it really helps make sure that everybody's aligned. So this is when I'll actually get a chance to meet with the contractors and give them an overview of what my expectations are, and really go through the entire system piece by piece. So what we want to discuss, the very first thing, control intent narrative and sequence of operations, just like anything else. But then also going through the wiring expectations. So say, for instance, it's a wireless system. There might not be as much wiring as a wired system for the purpose of communication, at least. But going through, okay, there's some unique wiring, or there's no wiring here, just so that they understand where there might be labor, or where they overestimated labor or underestimated labor. And that through this meeting, there may be some change orders that come out because they didn't realize the complexity of the system. But oftentimes, if the documentation is clear enough, that surprise doesn't happen. Then there's going to be discussion about the startup procedure, and some manufacturers are very explicit about what that procedure needs to be, and we'll get into a little bit in the next slide what startup really is. But this whole meeting really helps verify, hey, this is what you need to do before we get into startup. Then what the programming testing procedures are going to be, who's going to program the system. Some systems don't need a technician brought in. The startup and programming can be done by the contractor. And so if the contractor didn't anticipate doing that programming, that will probably turn into another change order. But oftentimes it'll be explicit enough that in the sequence of operations or in the documentation saying the contractor is going to be providing this, so please include that in your estimate. Then finally, there's training and support, making sure that the end users are trained appropriately for the system. And having this pre-startup meeting is really crucial. So having it scheduled early, oftentimes even right after my approval for the submittal is sent out, I'll send out a follow-up email saying, hey, we should have a meeting to go over this submittal just to make sure that everybody understands what's expected from the system. And so that way it really helps prevent the rework or additional change orders from field discovery or discovery of lost scope. So it just helps have all of those procedures kind of preempted. So startup is talking about when you first energize the system. So when you first put power to the devices. And sometimes manufacturers are really strict about how you go through the startup procedure, primarily because they've been burned in the past by having the contractor either, not set it up correctly, not wire it correctly, and they turn the energy on and they fry a number of devices because they were miswired. So a lot of manufacturers will say, we need to have somebody go on site and inspect before we can get into startup to make sure that it's wired correctly, or things are not going to, get fried because of incorrect installation. And so because a lot of lighting controls devices are low voltage and very sensitive. And so if low voltage devices are connected to line voltage, they will oftentimes just be irreparably damaged and need to be replaced. So a lot of these manufacturers will have what's called a startup form, which needs to be filled out before they will send out a technician or a certified partner to the site to verify that, yes, this is all installed correctly, and yes, you can now energize everything, and we can go into the process of programming the system, which is the next thing. So programming really is how you configure the system. So now the system has power, but it's not going to behave right out of the box ready to go. So a programmer technician needs to go device by device or room by room or space by space and program per the sequence of operations. And this is why it's important to have really explicit and clear sequence of operations criteria to make sure that when the programmer goes through, they can really meet that criteria. And oftentimes you'll see this done by a certified technician, although you might, if you have an integrator involved in your project, see an integrator following the sequence of operations and doing the startup and programming. Or contractors can sometimes do this depending on the complexity of the system. And advanced users, sometimes I'll even do some programming myself just to fine tune something if I know how to use the system. And so really when scheduling a site visit, it's important to make sure that the appropriate people are there. Depending on the complexity of the sequence of operations, if it's, again, very simple office space, on-off vacancy sensor control, you might not need to really hover over the programming. But if it's really complex, if it's color changing or it has unique requirements, oftentimes you might require the owner to be present, the designers to be present, the contractor may even need to be there, IT for the building might need to be there depending. So there might be a number of people involved that might need to be present at the same time. So coordinating that and making sure that the site visit has all of the appropriate people might be a little bit of a challenge to do. So making sure that that expectation is outlined early on through this process, especially during the pre-startup meeting. That's a great time to mention, by the way, we're going to need a very thorough programming. And so documentation and backups are really critical to making sure that if something were to happen, so for instance, if a power surge hit the system and the entire programming was wiped, all of that can be restored fairly quickly. A lot of systems have the ability to be backed up via like a thumb drive or something, but if even in those cases, it's still good to have some handwritten or typed up documentation that can be referred back to if the programming is very fussy and you really need to make sure that things are reset to a specific point. So calibration for daylight sensors or set points for your scenes, all of that really should be documented thoroughly enough that should something happen, the entire programming doesn't have to be redone with everybody on site again. So if you have, your owner, your IT, your integrator, yourself, other designers involved, all sitting in the same rooms going, yeah, let's adjust there, let's adjust that, let's do this, let's do that. All of that should be thoroughly documented and backed up so that way you don't have to bring everybody back in. All right, so how do we make sure that the system is behaving correctly once it's been programmed? That's how we come to functional testing and the acceptance process. Functional testing is going to verify that the system is behaving the way that it was specified. So it might be per the owner's project requirements or the sequence of operations or other documentation out there. But at the end of the day, this is, going to look at all of the documents that are pertaining to the lighting control system's functionality and go through it like a checklist and say, does it do this? Yes. Does it do this? Yes. And if it doesn't do something that was stated, then it becomes a problem that needs to be resolved, oftentimes through a punch list. But if the system's not programmed and not behaving the way that the specifications were stating that it should be, then that becomes a responsibility of the installation team or the manufacturer's technician. And additionally, codes or jurisdictions might have a specific definition for what functional testing is. And so making sure that the functional testing adheres to the code requirements or the jurisdiction's requirements can be a little fussy, but at the end of the day, functional testing is not just a term, it actually means something in specific jurisdictions. But oftentimes you'll see functional testing is performed by a third party or a commissioning provider. This is where the word commissioning sometimes gets used to refer to startup and programming, but really commissioning is an entire process. It covers the entire project from beginning to end. And you might see the commissioning provider most prevalent within this period because they're going through system by system, making sure that it meets the intent and kind of flagging things that aren't meeting intent for the installation team to be addressing. And so that's where commissioning can come into play, being referred to that way. But really, when you use the word commissioning, what it should be used for is not for programming and startup. It should be used for the entire procedure, the process of wringing out the system, making sure that the intent has been met. And so the acceptance criteria for a functional test should be measurable and traceable. And so that's where the sequence of operations set points are really handy, because then the commissioning provider or the third party doing the functional testing can go through the sequence of operations and say, yes, this is the timeout and it meets that timeout requirement. This is the daylight set point and it meets that daylight set point. And so they can really clearly measure and trace whether things are adhering to the specification. Then the last thing that is oftentimes forgotten, which is sad, is the ongoing support, making sure that the system actually continues on past the project's lifespan. So the very first thing is training the end users, making sure that they know how to interact with the system. So this should happen right before the project closeout, oftentimes when things are just getting polished up and cleaned up and ready for people to occupy the building or the space. This is when training is best to happen. It's best to identify the ideal groups that should be trained. It shouldn't just be anybody. It should be the people that are actually going to be interacting with the system. So in some cases, it might be maintenance staff, or it might be a facilities manager. It might even be, if, say, for instance, a theater, it might be the theater personnel as opposed to the facilities manager. And so really identifying which groups should be trained is important to do early on in the process, and then kind of schedule that training and make sure that they have been given this training on site with the equipment that they're going to need to be using. That way they aren't just being trained in sort of a sterile, unclear and unrelatable environment. It is their equipment that they're working with. They understand it. And also it's important to record sessions. This way they can refer back to the recording instead of having to call for support all the time, although some groups might never watch the recorded session and prefer to use the support phone hotlines. But at the end of the day, it's really just giving them the resources that are going to be best for their success with the project, which includes a document known as the Operations and Maintenance Manual, or O&M. It's also referred to as the Owner's Operations and Maintenance Manual. But at the end of the day, what this document is just the long-term reference document. It should have everything that is up to date. So the drawings, the settings, the reports, any contacts that they need to have to reach out for support, the submittals, the approved submittals, what's referred to as the as-builts, which is the revised drawings to reflect what actually got installed rather than what was anticipated to be installed. And we see more frequently these are being delivered digitally. It used to be you would get these massive 3-ring binders and it would have everything printed out, but nowadays it's more common to see them handed over in like a thumb drive or a large file transfer. And what this does is it enables the maintenance staff or the staff in charge of the lighting control system to do their jobs. So if they have a question, how do I deal with this device? How do I program this device? They should be able to go right into the O&M and be able to find that information quickly and easily. And if they are savvy enough, they might even be able to reprogram some things. So it's important that this document is really thoroughly managed and completed so that the owners can really take advantage of what documentation there was created for the project. Then finally, post-occupancy. This is when the occupants have interacted with the system enough to become familiar to the system. So new lighting controls, if somebody's just familiar with light switches or very simplistic automated controls and they're going into a brand new high-end lighting control system with tons of automation, it's going to take time for them to understand all of the parameters of the system and become familiar with it, and hopefully not, be frustrated by the new stuff, but more, encouraged by what's going on. But at the end of the day, you still need to have adjustments. You can best guess all you want as a designer and a programmer what people are going to need for their programming, but they will oftentimes say, oh, this timeout is too quick or too slow, or I really need more light rather than less light in this space for me to do my job. So there's always going to be those fussy readjustments that need to happen after people kind of interact with their system. So it's recommended that 2 return visits are scheduled. The very first one, maybe about 6 months in, just for the fussy minor tuning or any issues that have come up but never mentioned to anybody. So having a walkthrough with somebody who knows the system enough that they can give you feedback about it is going to help make sure that they're satisfied with the system. But then about 2 years afterwards as well, because at that point enough time has happened where people have really grown comfortable with the system, they understand it, and they really now can say, oh, I really wish this could do X, or you know what, we thought we wanted this but really don't want this, so can we eliminate this? So having that more thorough conversation at about the 2-year mark really gives the project high success rate, because of the fact that the end users are going to feel more comfortable with the system and that it really does meet their needs rather than just cookie cutter needs. But the goal here with these revisits is to focus on how they're using the system, how satisfied they are with the system, and whether the performance of the system aligns with not just your intent, but their intent as well. And that might evolve over the lifespan of the building. And so as a result, again, having these follow-up visits really helps ensure that at the end of the day, the system's going to be used effectively. And then finally, there's ongoing services. So ongoing services are cropping up more and more to support projects, primarily because systems will oftentimes need software, firmware updates, and periodic tuning, as I mentioned, the fussy calibration stuff. But also, having somebody on standby for troubleshooting any upgrades. They might want to expand the system, or optimization if, over time they're adding or removing, stuff from the space, or they're reconfiguring the space. Having that on-call support can really help them through these kinds of revisions. And we're seeing more and more local dealers and integrators are offering these ongoing service packages to the projects, and because they're local, they're really good for quick response. Oftentimes integrators can even set up remote capabilities, so they can just over the phone modify the system remotely from the project, and they don't even have to schedule a site visit to do that work. So these are becoming more attractive, and they really support the project's success. And so by having that ongoing support, you're really gonna see a bit of a satisfaction increase rather than decrease. So it is worth considering it and suggesting it to your clients if you're working with them, saying, hey, I'm not going to be here forever helping you through this process, so it might be worth considering having a local group supporting you through this project. All right, this concludes part 3 of the lighting control system design course. This part really just covers the follow-through, the construction and post-occupancy phases, and everything that kind of goes in between those, how you kind of help support the project wherever you are as a role, whether you're a designer or whether you're a manufacturer's rep or a contractor, all of this, information should hopefully help you, but especially if you're a lighting controls designer, so that you understand how to make sure that the system is properly, coordinated. Because at the end of the day, a lasting success for your project is going to come from clear documentation, thorough coordination, and effective training. Thank you for joining me, and hopefully you got a lot out of this. This is not the end of the video series. This is just the beginning. So hopefully you will see more from the Lighting Controls Academy in the near future. But thank you for joining me. I'm Webster Marsh, the Education Manager for Lighting Controls Academy, and hopefully I'll see you in the next one. Before you go, a quick word about who we are. For over 25 years, the Lighting Controls Academy has served as the voice of the lighting controls industry. As a coalition of the National Electrical Manufacturers Association, or NEMA, we were created to help educate the public on lighting controls technology and real-world applications. Our hallmark program is our online education, including this video series, along with written courses through NEMA Academy. If you want to keep learning about lighting controls, head to lightingcontrolsacademy.org. You'll find articles, industry news, new products, award-winning projects featuring controls, and plenty of other helpful resources. Thanks so much for watching, and hopefully we'll see you in the next one.